Yo, what's up, y'all? We are going to write and graph systems of inequalities from word problems. So let's go ahead and do it. I just have a couple examples. All right, so check it out. I just went to Shipley's this morning. Okay, so I'll be honest. I wrote this a couple weeks ago. Went to Shipley's that morning, but I only had $8. But your boy wanted kolaches and donuts. So it's asking us to graph the solution set if the kolaches are $2 each and donuts are $1 each. Okay, so let's go ahead and graph this. So I want both kolaches and donuts, right? Okay, so let's define our variables. Let's say that x are the number of kolaches, and then y will be the number of donuts. All right, so I want both kolaches and donuts, so x is going to be greater than or equal to 1, and y is going to be greater than or equal to 1 as well. Let's see, I only have $8, and kolaches are $2 each, and donuts are $1 each, so I'm going to have 2x plus y, and that has to be less than or equal to 8. All right, so now all we have to do is plot all three of these inequalities and see where the shading intersects. So let's go ahead and plot these. I'm gonna do these in different colors, I think, too. All right, so let's go ahead and go to pink. So this is going to be in pink. X is greater than 1. So here is that. We're shading over here. Okay, now for red, y is greater than 1. So here's a line. And we're up here. Now we need to graph 2x plus y is less than or equal to 8. So the y-intercept will be 8. So let's go ahead and graph that. 4, 5, 6, 7, 8. So here's that. Let's do this in yellow. And then the x-intercept will be at 4. So that will be right here. Draw this line. And it's less than or equal to, so it's over here. All right, so our solution set, I'm gonna graph in green, is right here. So these are all the possible solutions to our system of inequalities, right in this green area. And that's all you have to do. So let's go ahead and keep going to the second example. All right, so the problem committee must have in between 5 and 8 members, consisting of juniors and seniors. There needs to be at least 2 of each juniors and seniors. Plot and write a system to represent this situation. Okay, so the prom committee must have in between 5 and 8 members. Okay, first let's go ahead and define our variables. So let's see, number of juniors. So let's have x be the number of juniors, y be the number of seniors. All right, so the prom committee must have in between 5 and 8 members. So that means x plus y must be in between 5 and 8. Let's make this inclusive. There needs to be at least 2 of each. So x has to be greater than or equal to 2, and y has to be greater than or equal to 2. All right, so we need to plot and write a system to represent this. Let's go ahead and just draw the first quadrant, something like this. All right, so let's go ahead and do x is greater than or equal to 2. So that'll be right here. So we're going to shade over here. Y is greater than or equal to 2. And now this is kind of interesting. So x plus y is in between these two. I'm actually going to go ahead and split this up into 2 different ones. So this is, you can think of this in 2 different ways. The way I like to think of it is this as two separate inequalities. So I'm going to have x plus y is greater than or equal to 5, and then x plus y is less than or equal to 8. Okay, so I need to plot this. So our first one, let's do this in green. The x-intercept is going to be 5, and the y-intercept is going to be 5. So let's plot that. So here's this one. And it needs to be greater than this. So it's going to be upwards. And then for this last one, I'll do it in orange. So our x and y intercepts will be 8. Plot that, and it's going to be downwards. I know this is a huge mess, but the place where this was all shaded is right here. So you just have to see where all of the shading intersects, and that's going to be it. All right, so that's going to be it for this video. Hopefully it made more sense. So see ya.